Okay, Seb, you ready?
So you want me to take
You
us
do
in?
the intros.
Okay,
Yes,
sounds
I'll take
good.
us in. You do the
Yeah, sure.
intros. No, I mean you do the
Wait.
welcome to Kotlin.
I do the welcome to talk, Kotlin.
You do it all.
Wonderful.
Yeah.
This
Okay.
is, by the way,
All right.
this is actually the hardest part of the episode. Always. We are very bad at communicating this stuff.
Okay, let's go. 5, 4.
And we are back with another episode of Talking Kotlin. Hello, everybody. It's nice to be here, and someone else is also here. That's Hadi. Hey, Hadi.
Hi, I'm still here. How are you doing, Seb?
I am great. I'm just wonderful. I'm honestly itching to get today's episode started. So what I suggest is we bring our people in here, we get through the weather, and then we talk a little bit about Arrow and Arrow analysis. What do you think?
But we could do all that. Yeah, sure. But I have a little. I want to just mention. I watched your video the other day on Kotlin context receivers.
Mm-hmm.
Well done, Seb. That was a good
Oh,
video. That was a
thank you.
very, very good video.
I appreciate it.
Video. Do you see what I did there? Video.
I
Say video.
video.
Okay. I got a German friend that can't say V. He says video.
Video. Okay.
Video.
Wonderful.
Anyway, yes.
Wonderful.
Yes. Wonderful. Wonderful.
All right.
So who are we today? I mean, we know who we are. Who is with us today?
We have an all-star cast as usual on this show. Shouldn't be surprising anyone at this point anymore. We have Simon, Raul, and Alejandro. Simon is one of the maintainers of Arrow. He's one of the lead software engineers at 47 Degrees. Raul is the co-founder and CTO of 47 Degrees and also one of the maintainers. And then there's Alejandro, who, at least according to Raul, is the smartest one of the bunch. But also he's a formal methods engineer at Twig. Welcome to the show, you guys.
Hi, I'll take it the smartest thing over the other thing. I like it more. Then I make it my title.
Yeah, honestly, I think you can put that in your Twitter bio right now. I think that's an endorsement worth showing off. How are you folks doing today?
Pretty good. How about yourself?
Excited. Also the weather is nice. So
Hey, we decided to stop that. Remember, Seb?
Really?
We said
Did
no
we?
more talking about the weather.
Did we? Wasn't there?
Nah, I'm just joking.
Yeah,
I'm kidding.
We'll never stop.
No, exactly. Actually, so I know where you are, Raul, and I think I know where you are, Alejandro. I don't know where you are, Simon. Where do you live?
I live in Antwerp, Belgium.
Okay.
So I'm pretty close by everyone.
Oh, sweet.
Yeah.
So let's go through the weather then. Out here, it's actually nice and sunny. There's a couple of clouds in the air, but I'm just looking forward to when it cools down in the evening, so I can go for a little bit of a jog. How's the weather in Belgium?
Today we actually have a really nice day. It's very clear, sunny, which is really nice for this time of year.
Sweet. And how about our folks in Spain over here?
You know, Spain is a big country, right? I mean,
Sure,
like,
but I mean,
how's the weather in America? Oh, well,
yeah, but you realize that when I think of Spain, I literally just think of like beaches and like sunny weather all the time, and like people like eating ice cream.
and playing the
Sorry for the
flamenco guitar,
cliches.
right? Oh, by the way, Raul, is that a flamenco guitar hanging?
Yeah, that's one of my old Spanish guitars that I had as a teenager.
Okay, so we gotta listen to you play some Paco de Lucia later on.
Yes, not today though.
Excuses. Yes, but going back to the weather, I'm in Malaga. It's fine. I'm guessing that in Cádiz, where you are, Raul, it's fine. Where are you, Alejandro?
I'm actually in the Netherlands, so I'm. but the weather near Amsterdam is pretty nice too. I mean, we always share the weather with Belgium, so
Yeah. Sorry, Raul, we cut you off. How is the weather in Cádiz?
It's actually a little bit cloudy today, so it's unusual because it's usually sunny. But here in Chiclana, Cádiz is a bit cloudy. Maybe it will rain.
Yeah, you know, we had some friends of ours that came over from Canarias, which is an island somewhere over there, 1 hour behind Spain. I mean, in time zone, and they have a lot of Kalima, which I don't know how you say Kalima in Spanish, in English, but it's basically the Sahara suspension cloud kind of things. And I've been in Malaga for 40 years, and I think I've experienced that thing like 3 times. And she's like, we get it like 3 or 4 times a month. I could not imagine living with that so much. It is horrendously bad. It was really, really bad here in Spain. So yeah. Anyway, moving on.
That's right.
To new directions. Did you get that? Arrow? No.
Oh, that's wonderful, amazing.
I'm trying
truly
to,
amazing.
you know, I've been spending so much time trying to improve my, what is it called? Segues?
Yes.
Segues, and you don't even appreciate them.
Well, you know, they're so smooth, they're hard to point out at this point even. So today we're going to be talking about arrow and arrow analysis, because that certainly seems like you would be the right people to talk about with. And I just want to quickly read, because Hadi loves elevator pitches, it says on his homepage. Just want to quickly read the elevator pitch that I saw for arrow analysis, and then I think we can spend the next however long unpacking those 2 sentences. So it says here that arrow analysis is a plugin for the Kotlin compiler which supercharges your compilation pipeline with new checks in order to make your code safer and more robust. It's also the first public plugin using the Arrow Meta compiler framework.
Okay, that's actually good marketing. Although I would drop the whole, this is also our first public plugin, because at some point it won't be, and then you'll have to update all your brochures.
It will always be the
But it would always be the first, right?
It's not the only, it's the first.
Oh yeah, true. Okay, and that's why I'm not in marketing. Anyway.
Our VP of communications, everybody.
Shut up. Right. Okay, so that's a lot to go through for folks that, I guess for folks that haven't heard of Arrow, does it make sense to even like briefly mention what Arrow is, or is that out of scope for this particular plugin?
I think it's in scope in the sense that Arrow is a family of libraries, but more importantly, it focuses on the Arrow effects and the Arrow core library. And this compiler plugin also gives you or provides a set of techniques in a way, like a set of refinements over the types, and interacts with the type system in a more deep way that you could do with just a regular library. So they're somehow related in the kind of field or domain they're on, but they, of course, like serve different purposes. Both work for domain modeling, though.
And let me follow that up with another question. Do people need to understand Arrow or Arrow effects or the likes in order to use Arrow analysis or get started with it?
Maybe if I can answer this one. I don't think so, because we can see Arrow more as an open source organization. And if I would have to say or give a single sentence as a mission statement for the Arrow organization, I would say it would be bringing functional programming patterns in an idiomatic way to the Kotlin language. And Arrow analysis does that in a very different way than some of the other Arrow libraries that are under the Arrow organization.
Now, kind of the end goal of the whole organization is, well, let's try to bring this kind of functional features to have like safer or better type features in the language, and some of those can be done using just the library code like Arrow. For some, we bring some compiler plugin, some library like with optics, and some are just compiler plugins like Arrow analysis. So the whole idea is, let's bring this idea of functional domain modeling and a strong typing more into the Kotlin ecosystem. And I think that's like the overarching theme of the whole organization.
All right. That actually sounds great. Because I think both functional programming and making types more expressive. Those are all things that the Kotlin community is always pretty excited about. So I personally really like anchoring my thoughts to some kind of certain examples instead of just talking on the abstract level. So could you give us some insights on what I can do when I add arrow analysis to my project that I couldn't have done before?
Right. So maybe the simplest thing you can do is, for example, check that every time you are using a list and you are taking the first thing, so you call dot first, arrow analysis will actually check that those are correct. So that you either have made a check somewhere else in your code that guarantees that this call to first will be okay, or it will tell you, sorry, this may end up in problems. It might give you problems later, and then you can replace it with first or null, or actually what it's supposed to do is you actually introduce this condition that then checks, and then you know that you've covered every single thing. So that's that's how you can use it as a let's say consumer of this kind of conditions. So arrow analysis is kind of a plugin, but also we have annotated every function in the Kotlin standard library with these kind of things. Like, to use first in a safe way, you need to have a list which has at least one element. All these kind of things are added, and these are extra checks that will done during compilation time. So that's maybe, I think, that the smallest thing. So if you add arrow analysis and then you write empty list dot, let's say, get 3, then you will get something which says, sorry, you need to have a list of at least 4 elements for this to be okay. So it will fail at runtime. In this case, it will always fail, but in other cases, it could also be that you can make the check yourself, and then arrow analysis takes care of keeps track of, okay, this list, I know it has 5 elements, so this thing is safe to do at this point. So this is the kind of thing that arrow analysis can do.
And if you know, like, Kotlin contracts, arrow analysis is very similar in the sense of, like, it tracks the data flow and it allows you to add constraints to functions and places where you would say information about what's coming on the arguments. But it's more advanced in the sense that it allows you to use not just Boolean and nullable types, but other more complex types and expressions and relations between the types.
So does arrow analysis add new syntax to the language then in order for me to express these kind of conditions? Because I assume I have to at some point tell the compiler I can guarantee that this operation will always return a non-empty list or something like that.
So we essentially use the requires part to have like the preconditions, so the thing that the arguments need to satisfy, and then at the end you add a small, we call it post condition block. So you write post, and then what is supposed to be true at the end of this function. So it's a lot of what has to be true to call the function, which will be checked then, and what do we know that it's true at the end of the function, and this is checked in the function. So this also can give you a bit of warranty. So if you think that the function you've written at the end should not give you an empty list, you write it down, and then the compiler checks it, and then also when you call this function, we know this is true. So this is it. It should be quite. It's essentially the same thing as writing a requires block, but you have an extra argument which represents the result, so you can talk about the result. So it should be clear. It should be quite familiar to people already using the contracts functionality in Kotlin.
Right. And I assume I know the answer to this, but I want to kind of make it clear because when we've done the introduction, and all of you are very well known for your liking, I would say, to functional programming. I mean, am I correct there that you kind of like functional programming? Yeah, a little bit.
Kind of.
Yeah. So to not dissuade people that aren't doing functional programming, this is not only applicable to when you're doing functional programming. I assume you can use this in all cases.
Yeah, right? Not at all. I mean, it. As I said, that's that's if you think of this overarching theme I was mentioning of Arrow, this is going more into the part of having a strong touch, but you can use it, for example, to introduce a class and say, well, in this class, when I use this class, this thing should happen. So, for example, I don't know, you have an age field, and this should be always greater than 0. So these are checks which apply to whatever style you are using. In fact, if I'm very, very honest, right now the main thing where sometimes arrow analysis says, well, I don't know what's going on, is when you use very complicated higher order functions. Sometimes those are hard to check because it's like, things can go on, functions can be called more than once, so it's hard. But yeah, I mean, it goes on this same idea, right? Like, you want to check, for example, whether your list is empty or not, and people from more functional programming community would say, well, introduce a new type, non-empty list, and that's something that it's done. And another way is what we do in arrow analysis. Somehow tag your value saying this is a list which satisfies this property. So it's just two ways to, at the end of the day, achieve the same goal.
So generally, I think reasoning about these kind of things is probably the quote unquote the easiest when they're like immutable lists, right? Or when they're read-only lists. Is this also something that you've introduced for other collection types? So for mutable lists, or do you have some kind of integrations for making sure that multi-threaded applications also kind of can still validate these kind of conditions? What's the state there?
So right now we don't have something specifically for multi-threaded application. What happens right now is that something could be potentially mutable, then by default, we cannot warranty things. It's a bit like when you have a when block and you have something which could be nullable, and then you check it, but then if you use it again, you somehow need to have an immutable mirror of this. So this is a bit like this. So if my age field, for example, should be greater than 0, and I access it, maybe I access this again, and I can no longer warranty this. So when we have mutability, essentially we sometimes say, sorry, but this thing, we don't know whether after checking this still works. So what we've done, and hopefully we will be able to do this in the future, is introduce something which we call invariance. And the idea is that if we check on every specific use of this mutable variable, then something holds, then we can still assume it even if we are mutating it, right? Because we are somehow promising this is going to be the case. And of course, I mean, you can. This is all at compile time, so you can still defeat it using reflection, and bad things may happen. But that's the idea, that what we do then is we attach to this mutable thing, be it a variable or be it a member of a mutable collection, some promise, and then if you always keep your promises, then we can take it for granted later on. But that usually makes everything a bit more complicated because when you have immutability, you can assume things when you are using it, and here you have to attach the invariant at the very beginning of your program, so to say, and keep this promise. So sometimes it gets hard to know what to write there. But that's a bit how it works using this invariance.
And I think that it's because you've mentioned this a couple of times in terms of strong typing and correctness. I think that this is one of the things that folks that are fans or promote or love functional programming, one of the things that you strive for is this exact thing, right? To kind of guarantee correctness of the application even before execution. Kind of somehow saying that, my like someone said, if you write a Haskell code and it compiles, you know that it's going to perform correctly, right? This is
I hope that was true,
right? But pardon?
I hope that was true. I mean, I've had my first share of Haskell programming. But yeah, it goes in that direction, right? It goes in the direction of write more types and put more effort on the compilation. So hopefully you will be able to save you problems later on. I mean, you won't have this call about a bug popping up or having to spend too much time debugging stuff. So that's a bit of the promise, right?
Yeah. Raul, Simon, feel free to participate more.
Yeah,
Will do.
error analysis is really Alejandro's project. But yeah, just to maybe come back on that last thing you mentioned, I think it's very similar to the goal of test-driven development, where at least for me, functional programming helps me make the feedback loop shorter, so that the compiler and the types in my program will actually tell me when I make a mistake without me having to go as far as even run the test. So even before running the test, I can already know that there is something wrong in my program.
Let's maybe also talk a little bit about the relationship then still between arrow analysis and the rest of arrow functionality, maybe, because, well, we've already briefly heard the word optics before, and when I think, oh, I probably shouldn't be using mutable structures here, but I still have them deeply nested, that's usually when also people shove optics in my face. Can you maybe give our listeners just a quick introduction to that, and maybe also how then it relates to analysis, if it relates to analysis?
So Arrow Optics is a project, or one of the other projects under the Arrow organization, that tries to complement, I would say, the language. So all the libraries in Arrow are a company library to something. I would say the optics library accompanies the language in the sense that it tries to provide something like the copy method for data classes, but on steroids, I would say. So it helps you to update and work with immutable data in an elegant way. And it does so by providing a couple of extractions, and with a compiler plugin offers you a DSL to very easily work and manipulate immutable data. That's a nice summary of what Arrow Optics does. With that being said, maybe a slightly related topic, we are actually, or I am very hopeful for the immutable data structure keep or proposal that Kotlin has. And I'm very curious that if it covers the same use cases, then Arrow Optics might disappear, because, as I said, it's a company library to the language. So if the language offers the same functionality, then the library in Arrow will disappear.
Is that something that feels good or something that feels bad?
I think it feels great.
Yeah,
it's really good. Yeah, I mean,
good.
this is one of the pain points that we felt in Kotlin, and if there's a better or a more idiomatic solution in Kotlin itself, then I think that's the celebrations for everyone. And having to maintain less code is also always good. So
we also have an example of that when in Kotlin the suspend functionality really matured and more people were using it. We got rid of all of the I/O and all the data types that we had to model effects. So really our purpose is like, if we're using something and it gets added to the language, or there's a better option for it for the entire community, we don't want to maintain it in Arrow, for sure. So great.
Yeah, I think that is very nice. And in fact, we have the history of, I remember, Raul, when we were discussing the two functional programming libraries that used to exist in the Kotlin ecosystem. And you were very adamant in saying we should do what's best for the community, right? And if that means joining them into one, that's the best thing. Now, coming from other communities, there's also a certain level of backlash around this idea, in that, I'm not saying that Kotlin or JetBrains or anything from the standard library could be interpreted as the mothership or something like that. But this idea that as a team, as group of folks in the community, we put something together, we put an effort, and now comes along the standard library and does the same thing, doesn't that demotivate folks from trying to innovate in the ecosystem?
I mean, I don't think this is actually removing innovation. I think it's actually something I really like about Kotlin is, for example, how open the compiler plugin API is, which means we can prototype this kind of features, like optics and analysis, and they work well. I mean, once you're using it, they really become part of the compiler. So we can prototype those, and maybe people will keep it. So I actually see it much better than other communities where you need to create your own modified version of the compiler or whatever to introduce things. So I'm just saying that I don't see this as actually removing innovation. I actually see that this opens the space to try new things. And, I would actually hope that many of the things we do will eventually become in the actual compiler instead of as Samu was saying, us maintaining our own thing.
I see it as a promotion of some of the features and ideas. In fact, some of the things that since we've been working with the compiler plugins, we've been talking to many folks from the JetBrains team, from the compiler team. Especially, I've been talking to Dmitry Novoslov, which he's shown me many of the features with the new front-end IR, and we are actually trying to build plugins with that. I'm not sure if I'm supposed to say this in public yet, but we are building a couple of plugins with the dev branches that they're producing, and all of that work we are seeing inside the compiler some new features like this context receiver proposal. Before that, we sent KEEP 87, many other proposals and other KEEP similars were sent. So I think all these ideas contribute to the bigger goal. And now we see we have like a really good context receiver proposal that works for all use cases, not just the type classes or the ones that we made up from our point of view, right? And I also see in the compiler now in the new APIs some features related to like type attributes, related to the data flow, to things that we might be able to use to improve maybe error analysis down the road. And I think in general, any idea that comes from one of the libraries like Arrow, which is not meant to be a single individual interest library, but more of a community interest library where there is many individuals, there's companies that are interested in its success or whatever. If they make it to the language, it's a win for them as well, because it's something that they don't have to tell people, hey, go and use Arrow for this, because it's already in Kotlin. So I think we're all cool with that.
I picked up on one thing in Simon's description beforehand, because you said that Arrow Optics also uses a compiler plugin, but also we heard beforehand that the first public compiler plugin running on Arrow Meta is Arrow Analysis. So now that, of course, makes me wonder, what's up with that? Why is it not on Arrow Meta? Is it going to be moved to Arrow Meta? Maybe we first need to even tell people what Arrow Meta really is, so that even this question makes sense.
So maybe I can. Okay, Simon, go on.
Yes, I was just gonna say very briefly. Maybe I misspoke, but what I meant to say was Arrow Optics is currently actually running on Google KSP. So if I'm not mistaken, it's running on a compiler plugin, but not through Arrow Meta. So
yeah. And if I can expand on that, basically right now the status of compiler plugins are, since the front end is changing to the front end IR, and before we have a descriptor-based API, this older API was used in CAPT and in other places to generate source code for plugins. This is going to eventually change. So we based early versions of Meta in these older APIs who are now going to change. And we never actually made a promise to keep them around because we knew that we were not going to be able to maintain them with this big change to front-end IR. So some parts, like the case of the optics plugin that requires source code generation, those we're using KSP for it. And other plugins like analysis, which require like data flow integration and much more deeper integrations, then we use the compiler APIs for it.
But, this proves the point that I mentioned earlier, that you should just drop the first public plugin, whatever, from your marketing tagline. Because if Seb is confused, I'm pretty sure other people will as well.
I'll say that we are so proud of. Arrow Meta is also something. It's you can think of it as utilities and things to actually build a compiler plugin, because otherwise the compiler API is a bit raw and has some edges. I guess because now it's moving to this new thing. So there was something. So this was built on top, and we built several plugins on top of this. So it's also been kind of a lot of work, especially from Raul's side, to make Meta a reality. So to have something which we could build analysis without fighting with the compiler, there is like this like pillow in between, which is Arrow Meta. It's just like an utility library for compiler plugin writers.
And to clarify, this abstraction layer, is this something that you're going to be like, are those APIs going to stay roughly the same as the compiler APIs evolve?
So basically, what Arrow Meta does is like wraps the compiler APIs with a functional DSL, such as that you can declare a plugin in terms of like the different phases, like analysis, code generation, resolution, whatever phase you want to modify in the compiler. In contrast, the compiler API is actually just a bunch of classes and listeners that you have to register and manage yourself. So it kind of like abstracts away that complexity, and it tries to follow the latest stable compiler APIs. So once FIR makes it there, we'll decide if Meta makes sense at all or not. Because if FIR, the compiler plugin API, when it becomes public, is actually better than what we have, then there's no point for it.
This is the series that Amanda Hinchman, I think, started, to write about.
Yes. Amanda worked in Arrow Meta. She's been contributing.
Cool. Okay, so I have a question coming back to this analysis thing, right? Because essentially what you're saying is that you annotate the standard library. And I don't know how many of you here are familiar with a tool that we have, which is called Resharper, which is kind of like the IntelliJ of the .NET world. It was a plugin for Visual Studio, kind of like what Rider is now, full-blown IDE. And we still do annotate libraries there. And then based on that annotation, provides a certain level of analysis. And so I've got two questions. One of them is, what about annotations outside of the standard library? And the second one is, where do you draw the line between, is this kind of like, part of the, like, this is an enhancement on the static analysis that an IDE could potentially provide, or as part of a linter or build tool, etc. And, is there a situation in which, as these analyses start making its way into the compiler itself or into the IDE, they now become redundant in your Arrow analysis plugin?
So let me maybe first answer the second one. So, I mean, our goal has always been that this kind of extra compiler check becomes part of the IDE somehow. And that's why we are kind of excited of this new plugin API, because it seems that you essentially can get the two for free. You write the compiler plugin, but this integrates great in IntelliJ and so on. Because now what we have is that if you run your build task in IntelliJ, and you have the Gradle output, and then you can click on the errors there, which is not as good as it could be, right? It's you have to do a separate step, but you can still get the thing. So, I mean, our goal is actually to have both, because I don't know, at least from my perspective, the sooner you get the problem, the better, especially in this kind of things where you are going to get most of the things are going to be, oh, you are missing a case here. What? Okay, click the button and add it. That's our, like, if we think of the promised land, that's it. Like, you have the error and a small quick fix button with add whatever needs, or adds the extra check, or put this on a test, or whatever. And about the first thing, so I mentioned we annotated the standard library, but that's actually part of Arrow analysis, and something which took us a bit of time to get working, is that you can actually annotate whatever library you want. So you just go and create another library, and you say, oh, this is the precondition for this function. I call the function. This is the post condition, and the system takes it into account. So actually, the whole we call it like loss. We didn't come up with a better name. So the loss for the standard library are just in a separate library. So when you depend on both the standard library and the loss, arrow analysis recognizes, oh, I have these functions, but these functions come without any law. But look here, this is a bunch of annotations, metadata, which tell me what should be the ones here. And we did it because we foresaw that, of course, we are not going to change the standard library itself. But not only that, like imagine you want to bring better types for Spring. Let's say, well, you just open a file and start adding annotations for a Spring. And this is separately distributed. It's just a different package you depend on. So the more laws you depend on, the better your other things may come. So that's a bit how it works. This is open. At any point, you can say, you know what, this doesn't have pre and post conditions, but I'm giving them to you. And we cannot check those because we don't have access to the source code, but we can still take it as granted somehow. And that's actually what we do with the standard library. We don't check that the standard library is correct. We assume it's correct, but we give better types that our analysis can use.
Yeah, and to be clear, I mean, this is a similar approach to Resharper, right? You don't have to actually touch the original library in order to provide these annotations. But it was more a kind of like a point of, what other libraries, common libraries, things that people are using that maybe they're not going to take the time to provide this annotations. Are you providing or planning on providing?
I think in when you look at error analysis, there is like a big difference between error analysis and what other linters, like maybe something based on rules or based on the actual code structure. With those, you usually can write some rules and you can find some problems, but you cannot find all the problems. So error analysis is similar to what you will have in IntelliJ IDEA for the data flow analysis, where you can track certain variable types, a few of them, and then tell you when you have unreachable code and things like that. But error analysis, I think it takes a kind of like a more, the approach it takes, basically, it takes all that information, all that data flow, and uses an Smt solver on behind to actually get back an answer as to which constraints are violated in certain parts of your program. So
can you just explain what a Smt solver is for folks that aren't familiar?
I'll defer that to Alejandro.
Oh, yeah. So an Smt solver is a clever black box. So essentially, it's a small library or program. So Smt actually means satisfiability modulo theory. So that's coming from the people doing logic. And the idea it's essentially something which you can say, I know that n is greater than 0, and I know that n is smaller than 0, and the Smt solver tells you no. I mean, this is false. Or you say, oh, n is greater than 1 and n is greater than 2. Oh, great, you can actually simplify it to n is greater than 2. So it's like a small reasoning engine that we use. So we are actually not doing any reasoning with an arrow analysis. We are just creating the right questions for this thing. And there are, if you go to Smt solver, they're incredibly powerful. They can do crazy reasoning. So we just go there, ask it, and if the Smt solver tell us this is all okay, we say yes, okay. Otherwise, and that's actually something we want to explore, it tells you, look, there is a case in which I couldn't prove it. And our goal at some point is to be able to reflect this back to the user and say, look, actually, it turns out that if your function is taking a list of 5 elements which are all 0, this is breaking. So there you are. Please debug your code with this thing. So that's like, but it's a magical box. For me, it's the most magic piece of software I know. I don't know how it works and how it can do it. It's extremely efficient, but that's what it is. It's a reasoning engine.
Sorry, if I can come back to your previous question, Hadi, but I also think it's very interesting about error analysis is that it takes into account existing functions in the ecosystem for checking invariance, for example, require from the Kotlin standard libraries taking into account. So if your library or code is already using the require function from the Kotlin standard library, error analysis will actually also take that into account as a law, as a precondition. and we can do similar things for other assertion libraries that people might be using in their code, and you can register them to the Gradle config to say, hey, this assert function, this custom assert function that we're using, you also have to take into account in error analysis. And in that way, you can enhance error analysis with existing code that's already out there for existing libraries that are already out there.
That's actually quite curious. By the way, just real quick for you, Hadi, I know that you have a history with .NET and you have a lot of love for it, but you actually don't even need to leave the JVM ecosystem to see the kind of annotation work that we've been doing at JetBrains. If you if you just have a standard Java project and you've ever seen where it says @contract pure for methods that come from the Java standard library, those are also annotations that IntelliJ actually adds. That's not something that's in there.
Yep.
But okay, so you've briefly said that this Smt solver is a magical black box, but that's also very efficient or very performant. And I think that's maybe one of the other big questions for people, because it sounds really computationally heavy to check a ton of conditions all over the place. So I'm just wondering, like, what will be the performance impact on my project when I add error analysis? Is it suddenly gonna come to a stop, and I'm gonna drink a coffee every time I rebuild, or what are we looking at?
It's Android.
Then you have bigger problems. I think what our test has been showing in our smaller projects is that normal compilation with error analysis takes usually like 3 times more than a regular compilation. That is not too bad if you just think about it as an analysis tool, if it's not continuously compiling or compiling a huge code base with it, because you are basically in a smaller loop in analysis as you are typing, and that's what we're hoping for the front-end IR, because at that point, it's not as slow as much as, it's considering not the entire program all the time, but considering partial parts of the program that can inject into a context, and they can retract facts and rules from that context. So it's kind of like a communication engine type of stuff. So in that sense, it's not too slow, but I would say this kind of analysis really increases the compilation time, because it has to do a lot more work to give you the errors that otherwise you're ignoring.
That's interesting, but does it also mean that does it mean that it integrates with I can't speak right now. Does that also mean that it integrates with incremental compilation? Like, are parts of your of the invariants, are these also then being cached, or is that planned?
No, that's
a small loop.
That's unfortunately something we haven't done. So right now it's a full, it's you compile your entire project with it. So that's the main problem that now you need to do the whole thing, and there are so many things you can cache in between sessions. Like there is, for example, quite some startup time. So what I mentioned, that the loss could come from a different library from the other thing. That means there has to be some search, which could potentially be cached, and so on. But if I remember correctly, the current compiler infrastructure didn't give us enough hooks to do it in a simple way, because it seems that it's really geared for this kind of compilation type, which you compile your whole project. But it seems that the new API is really giving you hooks for the incremental thing. So as Raul was saying, in theory, it's as easy as just saying, oh, these are the things I know from this function, but now they are wrong, throw them away, get the new code and run it there. So it should be, it's simple, given the right hooks to cache this information in between.
Yeah, the problem we have with the old API in the compiler is that it has a single analysis hook endpoint, service, where you are called in before analysis and after analysis is completed. And then if you want to do something with what you have analyzed, you have to rewind that phase and repeat the process. And that's kind of a limitation. But in the new front-end IR APIs, there's like several different phases which we can hook the right parts of the analysis to do the proper caching as it goes traversing the entire program.
But
So it'll check it. Go ahead.
No, it's sorry. Finish your thought.
No, I was just saying like, so it'll improve in the near future as soon as front-end IR becomes stable and we're able to adapt it.
Okay. But do you envision arrow analysis as something that you run every time you compile and test your program, or would you assume that it's something that stays more like an integration test, which you maybe run nightly or on CI to not get that impact?
You can choose either way, but I think we envision it as when you are in your IDE and you're in your editor, in that tight loop of analysis as you type, then it can work just fine, because that's not too slow to actually perform that partial analysis. Then we also envision that people will just like use it in their regular build or CI as part of a build step. So it can be used in any way. It's just a Gradle task. So.
Oh, okay.
Part of the build. So it hooks up as a compiler plugin, and you can choose to run it or enable or disable.
And what's the state of all this? I mean, is it ready for production for people to use it?
Yeah, I mean, the worst thing that can happen is you don't get results. So it's let's say when people ask me, it's like, I don't know whether you could even talk about production reading this kind of thing. So you can run it, and if you have a Gradle task, we think that it doesn't crash for any programs, but sometimes it will just say, I don't know if your program is correct or not, because I'm not understanding this. You're using mutability, and we don't understand what's going on. Something which I found that maybe we talked about some time earlier, but for example, we don't have an annotated Java library. So you go and use something from Java collections, then there is no annotation. So it will just tell you, sorry, I don't know what to do. But you can just use it right now, and as I say, it works, and it doesn't crash your compilation. So worst case scenario, you are having no further problems. That we are not showing you more problems, but it will never crash your stuff, right? We don't go into the code generation pipeline or whatever. We are not touching anything. We're just looking at it.
I love it. I love the standard of quality here. Well, we don't crash, so yeah, you can use it. It's fine. We don't crash. Yeah. I mean, we can guarantee that we don't crash.
No, I mean, we don't crash your program. We don't do anything.
But you can crash. We just don't crash your program.
Right. Yeah.
Right. Okay. I am kidding. No, this is very good, and I have to ask you one question, because I know that there's hundreds of thousands of listeners that are wondering the same thing.
Good one.
This segment on immutability has been brought to you by Rubik's Cube, which is not immutable. No, the question is what you folks have done as a team in regards to Arrow in general, not just Arrow analysis, but everything that you've done is really wonderful. And I think that many folks in the Kotlin community appreciate it. I'm not sure how many understand it, but many appreciate it. And that's that's a compliment. And when we're talking now, you're like, yes, if we get this stuff included in the standard Kotlin library or the compiler, etc., it is awesome, right? But I have to ask, because this is obviously a problem. This is mostly open source, if not, it's all open source. How do you maintain this? How do you sustain this work?
Well, in my particular case, through 47 Degrees, which helps Arrow with marketing and some other organization, we have the Arrow meeting for maintainers every week, and there's people from 47 taking the notes, making sure that we are following up with the tickets. That kind of help gives us back some kind of recognition from the community, and that I think that pays off. And I think also it kind of portrays the values of the company, being a company focused on correct software, functional programming, all these kinds of things. Being associated to Arrow is definitely a good thing. And then in the personal aspect, I was one of the original founders alongside a group of friends in Spain. They're still my friends. I've made many friends. Like, for example, I met Simon before he even came to 47 as part of the Aero community. I knew Alejandro also before. So it's been working with friends that makes it fun. And sometimes when you can justify with work, when then it's great. And when not, I still put time in the evenings. Like right now I'm working on Aero Inject, which is going to be a DI framework with the Kotlin compiler exclusively, so it doesn't use source code generation. And I'm doing that with Javier Segovia, which is a friend from the Aero community, also one of the maintainers. And that's like part of the fun of like, doing open source, like working on the projects you like with the friends and people you like. And sometimes it works for business and some other times it's just like personal.
Okay, so I should probably get more into open source to get some friends. No, I'm joking. No, but I think that for the purpose of like your business model, which is selling consulting, I completely agree with you in that this works well because it very much contributes positively to your branding, both personal and to the company branding. Yeah, sorry, Seb, I keep interrupting you, but
No,
it's okay.
It's all good.
I know it is. Go ahead.
What a power.
No,
move.
seriously, go ahead.
Oh yeah, thanks. Oh great, okay. You managed to derail even like the simplest thoughts that I have. It's uncanny. It's great. I actually just wanted to say that, well, I wish that we could make these episodes like 3 hours long, because I feel like there's so much more that we could talk about. I feel like we're actually just in the middle of everything, but we are unfortunately out of time for this episode. So I want to, first of all, thank you, of course, for coming on. And I want to ask one more question to kind of tie all of this together. You said in the beginning, or in the middle at some point, that you're always glad when Arrow functionality enters the standard library. So the question is, of course, after Keep 87, we got the context receivers. When the spend functions kind of got properly supported, you managed to convert some of your code. What should go into the standard library next? We're just gonna cut the silence. Don't worry.
Let's do a quick round fire.
Yeah,
okay,
just-
Simon,
Okay.
first, what do you want to go into the standard library?
Or let's say in the Kotlin standard ecosystem, because I guess it could also be in the compiler or the language.
Yeah.
Well, can I say two things?
Sure.
No,
There's-
only one.
I already mentioned arrow optics. This is something that I would really love to see in the language because I think it's valuable for everyone to be able to work with immutable data in a very much simpler and conciser way. And another thing that I'm really looking forward to or hoping to see at some point in the standard libraries are structured tuples, or maybe I have to say it in the language. Because currently we have tuple 4 to tuple 22 in addition to pair and triple. In Arrow core is something that I really don't like, and I really like the structured tuples that were mentioned in the 10 years Kotlin talk by Roman last year.
All right.
Raul.
I most in line with what Simon said and related to the tuple support, and I think this is kind of an advanced feature, but it's something that we need to solve the problem of the 22 arguments, not just in classes, but also the problem of RET in functions. So I would like to have proper tuple support in the compiler with some kind of way to express that a function has arbitrary number of arguments, and there are all of them typed. It doesn't have to be an H list. It doesn't have to do what other languages are doing or they follow to solve this problem, but a way to express a function that has an arbitrary number of types, and then that can later be extracted in the result type. That would be great. So better type level features for tuple and in general products supporting the compiler.
Alejandro, and you're not allowed to say the same.
No,
It's always the worst when you're the last person in the list.
no worries. What I would really love is to see some of the features of arrow analysis coming into the compiler, and I think like for example, Kotlin has made a great job in like the nullability front, right? That's a bit like an analysis, right? You suddenly have types in which you say whether it's nullable or not, and it can track some of those things. So I think given that many of the once you then have null reference exceptions, many things come from like number bounds, like you are overflowing or not, or whether lists are empty or not. These are also small bits of information that I would love the compiler to track for me. And arrow analysis, like you can track whatever you want, but maybe there is a way to track the most interesting things, the things which people stumble upon the most, and make it fast so we don't lose the fast aspect of the language. So I would really hope that some of those things creep into the analysis that either the compiler or IntelliJ is doing. So that's what I would really love to happen in the future. Yeah. And the type of thing. That's the. Now, I'm really very happy with the context receiver thing. So I mean, Simon and I spent some time trying to figure out how to do these multiple things using all kinds of combinations of weird objects and compiler plugins, and now we don't have to do it anymore because it's there. So that's.
Yeah, but you've again, like you mentioned, that some of the stuff that you've done has impacted performance. But I just realized that when we first launched Kotlin, one of the promises was that we're going to be at least as fast as Java. And I keep saying, we're not there yet. We're quite close, but we're not there yet. But maybe we could just make it easier and say, we're faster than Android. That could be the new tagline.
Cool.
Faster than Android.
What a way to sign us off. Yeah. If you want to learn more about Arrow, you can go to arrow-kt.io. I'm not sure, are there other social medias that you would like to shout out?
There's a Twitter account, and there is like a Slack channel.
Wonderful.
Yeah.
Then we'll also have links for those in the show notes below.
And definitely check out 47 Degrees. Awesome company, providing awesome consulting. Awesome.
Are you
people.
hiring?
We are hiring, yes.
Oh, there you're hiring. Yes.
Wonderful. There you go. They're hiring. So if you want to do awesome stuff,
did you say wonderful with a V?
Wonderful. Yes, of course. I sometimes just say wunderbar and people don't even catch on to it. Anyway.
Until next time.
Yeah. See you in the next one. Take care, everyone. Bye-bye.
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 Thanks for having us.
Thank you.
All right. I'm not sure if we're still doing these things, but also click the like button and the bell and make sure you subscribe. If you were wondering what this whole context receiver thing is about that the Arrow folks are really excited about, there's a video that we've linked right here. And I'm not sure if YouTube can make it possible, but the Kotlin 10 years video that was mentioned beforehand with the structure tuples,
it's going to appear right up here in the corner. Is it?
I don't know. Maybe it'll be on screen. I don't know how this works, but that's going to be great. All right.